So out of many components, see, this tractor engine, it is having a lot of commodities and it is having different components. Out of the different components, only oil pan, crankshaft, and water pump has been taken for the information phase to analyze the technical details with respect to the materials, manufacturing process, and then where it is been applied. Okay, and packaging means, see, packaging here indicates, so the crankshaft should get fitted properly and water pump should get fitted into properly into the engine. Okay, the fitment packaging basically they call. And is there any field issues? What is the production volume? What is the number of volumes? Okay, the tractor volume is lesser than the car volume. Okay, the cost drive. What are the cost driving factors? Good. Uh, okay, so this is the oil pan. Oil pan. It looks like this for a tractor, and this is the crankshaft. This is the water pump. And this oil pan is coming under casting commodity, and this crankshaft is coming under forging commodity, and this water pump is coming under the proprietary part having the high cost value. Okay, now I told you you need to go for a random function, which is nothing but a function of what is the function of oil pan? It support weight, right? It support weight. It also hold oil. It also hold oil. It also indicate the level of the oil. It will also help to mount the part, and it also resist the corrosion because it is made up of casting. The corrosion can also happen. So it also help for preparing the surface, dampening the vibration. Vibration is very much important. So normally you might have studied the vibration level. So whatever the say for this component, the engine is the assembly. For the overall vibration of the engine might be different, and the component available vibration should be higher than the natural frequency of the engine. If the vibration is lesser than that, or if it is equal to that, then the resonance or the failure will happen. Okay, so you need to understand the vibration point also. Um, okay, next coming back to the crankshaft. Uh, Crankshaft. What is the basic function of a crankshaft? To transmit torque and also translate motion, and it is having the mass weight. It should balance the mass. Why to balance mass? To reduce the torsional vibration of the engine, and it needs to reduce the friction and withstand so force, and it also good for carrying the lubricant because it is having the hole lubricant hole for reducing the heat basically, and it also mounts parts with facilitate rotation. And water pump. What is the basic function of a water pump? It pump the water. How it is possible to pump the water by transferring torque, by maintaining position, by facilitating the rotation, by locating part and mounting part and withstanding force. Next we go with the fast diagram. So three fast diagram is being made individually for individual component. First, I will talk about the oil pan. The basic function of a oil pan is to support weight. Why to support weight? To protect engine. Okay, a higher order function. How to protect engine by supporting weight of the oil. When you are supporting the weight, you are also holding the oil simultaneously. How to support weight by indicating level. How to indicate level by assigning parts and by applying force. Uh, the oil is being applied into the oil pan, some force, and parts gets assembled. It also indicates a level, and it is basically meant for supporting weight, and finally it protects the engine. Why it is protecting engine? Because if there is no oil, then again it may lead to the failure seizure. So this is design specification is the 9-liter capacity of the tractor engine, and then the other function one time and all the time function indicates the mounting parts, resisting corrosion, avoiding the leakage, dampening the vibration. Even this is for a 30 to 50 horsepower tractor engine, and the torque is 180 Newton meter, and the RPM is 1009 RPM. This is the update. It's an update. Yesterday we have seen some of the fast diagram of the crankshaft. The basic function is to transmit torque. Why you need to transmit torque? Either to enhance performance or to run the engine. How to transmit torque? By translating the motion by rotation and applying torque. The all the time function indicates reducing friction, balancing mass, carrying the lubricant, mounting the parts, standing. force. Our scope of project between the left scope line and right scope line. And similarly for a water pump, what the basic function of a water pump is to transfer motion by maintaining the motion. How why to transfer motion to rotate the pump and fan? How to transfer motion by rotating the water pump and by receiving the force and by applying the force. So this is the design specification of the water pump having 2000 RPM and the fan speed is also 2000 RPM and the fan position is almost 30 mm. Uh, the other function indicates mounting parts, sustaining load, and locating parts. Okay. So after fast diagram, what you have to do is you have to go for a function cost worth analysis. So this is the oil pan, this is the water pump, this is the crankshaft. So you need to list down all the function. You need to list down all the function. Okay. Then you should list down what is the function cost. What is the constant function cost? So this one is nothing but 100%. So if the cost of the oil pan is 1,000 rupees, okay, then 400 rupees goes to supporting weight itself, okay. 250 rupees goes to hold oil, 50 rupees goes to indicate the level, and 140 rupees goes to mounting parts, 30 rupees goes to resist corrosion, and 30 rupees goes to prepare surface, and 100 rupees goes to damping vibration. So this cost will take more time to understand because it needs a lot of experience to understand the cost. But what is in your hand is being in freshers. What is in your hand is the technical aspect is in your hand. So you can look for whether you can look for some basis whether how you can look for reducing the weight or how do you can do the design optimization, how you can do the material change. Those things you can do it because all these are related to technical aspect. Okay, good. Um, so here for supporting weight it is 40 percentage and you can the worth is only 25. Okay, on what basis they're telling you they can go for a weight optimization so that they can reduce the cost, and they can also do the volume optimization when they can bring down the 16 liter without affecting the volume means without affecting the function. They can reduce the 16-liter volume to 30 percentage of 16 liter. It can come down. And what are the other optimum possibilities? The water pump pulley. You can reduce the water pump pulley weight by almost 50 percentage so that the cost gets reduced. And the crankshaft also you can look for some optimization by looking at the web is there, no, that is basically it will add more cost. What is called web? This is the web. You can reduce this thickness. When you reduce this thickness you can reduce the weight so that you can reduce the cost, but you need to do a lot of analysis. It's not that simply you are reducing. You need to do the CAE, CFD, CAE in the sense the stress level you have to do, and you have to do some simulation to ensure that the failure is not going to happen. Next is the idea generation. So I told you the idea generation is basically a creativity phase where you're going to create ideas for the function. For one function, you can use n number of ideas. For example, here for this product support weight in the case of a product oil pan in a tractor engine. So they generated many ideas, some of which include to eliminate the stiffness support of oil pan by going for a higher grade material, and to use the sheet metal oil pan with ladder frame design for support. And I will take some other examples like to eliminate some non-functional ribs passes. And see, but when you remove or eliminate the bosses and ribs, what happens is sometimes the failure can happen because of vibration. So but you need to do some testing, some computer validation also you need to do, then go for physical validation. Okay, and again, you can also reduce the wall thickness of oil pan going for advanced manufacturing process. And by holding oil, you can go look for so you can reduce the volume basically from 16% you can reduce to 30% of the 16. And you can go for advanced with respect to the crankshaft. You can go for the material change from existing to SAE 1541. It is cheapest cost material, but at the same time, it will not having any quality issue. And even you can do some design and change with respect to the crankshaft, providing some slot with respect to the weight optimization and the web. And for the function called fit standing force, you can go for a heat treatment process. Yesterday, I given an example of a sprocket, right? So it was existing, it was the gas carburizing, and then after induction hardening, can reduce the cost at the same time, the ultimate strength and hardness of the sprocket is going to be higher, which means the performances will be higher, which means the value will be higher with lesser cost. So similarly, you can also apply here as well, but with a different approach. Okay. So I told you the evaluation phase, how to evaluate the ideas. Okay. So the idea is evaluated based on different aspects. So this is very easy for you to understand. So you have two methods. First one is the paired comparison method, and another one is the decision matrix method. So decision matrix name indicates decision matrix. So you need to decide the best ideas. That's the name of decision matrix. But before going to the decision matrix, you need to pair the ideas. Ideas basically with respect to different parameters. Okay, for this project, the cost, validation, savings, implementation time, and environmental sustainability is taken as a parameter. Different product will have different parameters. Okay, sometimes manufacturing also can be taken. Sometimes you can create ideas. Okay, but at the same time, you cannot do the manufacturing for the ideas whatever you have created. Okay, in that case, the criteria may be different. So for here, the criteria is for this oil pan, water pump, and crankshaft. For the tractor engine, the criteria is taken as development cost, validation, savings, implementation time, and environmental sustainability. The cost, why they have taken the cost? Because the cost is very much important to reduce. And validation, what is called validation? Validation is nothing but testing. Because when you do any changes, because I told you, you are going to reduce the volume, you are going to change the process, and you're also going to remove some of the weight. You're going to reduce the overall weight of the oil pan. So you need to do some testing basically to ensure that the failure is not going to happen. Then also savings. Okay. Uh, Even development, what is called development cost and what is called savings. Saving is nothing but how much cost you are going to save, and development cost is nothing but for testing. You need to have some cost, right? Because in engine you do a lot of testing like cyclic load test, resonance durability test, thermal shock test, cyclic load test, and also you do some of the vehicle level test. Okay, for all these tests, some costs are involved. Okay, for 1 hour almost 3,000 to 3,500 rupees. The testing cost will happen. Okay, and diesel cost is there. So there will be other additional costs. Okay, for testing. So all this put together, you need to take that. And again, implementation time. What is the time required to complete the validation? Okay, I told you many tests. Okay, so cyclic load test will happen for 1,000 hours. So for completing 1,000 hours, it may take 3 months time. And in 3 months time, there should not be any failure. If in case any failure happens, then again the implementation time will be getting delayed. What is the impact on the environmental sustainability? So all these have been taken as our priority for the third comparison. Okay, listen this very carefully. Very carefully you have to listen. Okay, I will be very slow. See, A, B, C, D, E stands for 1, 2, 3, 4, 5. 5 parameters as A, B, C, D, E. So you have to put it here horizontally. And vertically, what you have to put is same. Similarly, you have to put the same. But you don't need to put the A, because I will tell you that what is this all about. So here 10 points. So I'm going to compare A with B, A with B, A with C, A with D, and A with E. It means I'm going to compare development cost with validation, development cost with savings, development cost with implementation time, and development cost with environmental sustainability. So here Look at this very carefully, very carefully. Okay. So I'm going to compare this development cost with validation. So which is very much important for me, whether the cost or the validation. For me, the validation is very much important. Okay, because if you test the product, there should not be any failure. Okay? So validation is very much important than the development cost. Okay, even I can, instead of paying 3,000 or 3,500 for 1 hour, I can even pay 4,000 also. But during the testing, my product should not fail, right? So that's why I'm giving 7 points and 3 points to cost and 7 points to validation. So how these points are being coming 7 and 3? This is based on the cross-functional team. So yesterday I told you the cross-functional team. Who are all the cross-functional team in a company? Design team, development team, testing team, sourcing team, purchase team, marketing team. So these are all the people. Okay, they give the value basically. It's based on the cross-functional team, based on the brainstorming, based on the rating. Okay, 1 to 10 they give the rating. Even last example, infotainment, and even yesterday, Mr. Ranbir given you vehicle diagnostic, right? Even for that, the ideas have been selected based on these ratings. But yesterday, I think he directly gone with the decision matrix. But before decision matrix, you could also, means it is necessary to do this paired comparison. Okay. Now I'm going to compare the development cost and savings. So for me, both are very much important. Okay, cost saving also important and development cost also very much important. Five, five. So this is not my value. This is the value given by the team, by the cross-functional team. Okay, and now I'm going to compare this development cost with parameter D, implementation time, which is very much important. Time or development cost. So see, it will vary from case to case. So here they given more importance to development cost. Okay, 7 points they given and 3 points to D3. D means implementation time. So, and I'm going to compare A with E. A is nothing but development cost, and E is nothing but economic sustainability. So they given 6 points to A and E for 4 points to E. Okay, good. So far, I think you understood. If any doubt, you ask me. Immediately put it in chat box, or put unmute and then you ask me. Now I'm going to compare the validation with other parameters. So already I have compared the validation with development. Already I have compared here. Okay. Now I'm going to compare this validation cost B with C called savings, which is important. Validation is important, right? 7 points here and 3 points here. And when I compare the validation with implementation time, when I compare B with D, both are important. So each having 5 points. When I compare the validation with the environmental sustainability, P having 6 points and E having 4 points. E is nothing but environmental sustainability. Now I'm going to compare C with other parameters. So I need to compare savings with A, means development cost, C with A, B, D, and E. So C is nothing but savings. So already we have compared savings with development cost and validation. So already we have compared here. So now what I have to do is I need to compare the savings with implementation time. So savings is important, having 7 points and 3 here. And when I compare the savings with the sustainability, both are having 5 points. And the last one is implementation cost, implementation time. And when I need to compare this with the E category, both are having 5 points. Good. So now you listen very carefully. Now what I have to do is I need to score what for this each and every parameter. I need to put the score. See, I need to add the A value. A 3 plus 5 plus 7 plus 6 will be 21. Okay, so overall score for development cost is 21, and the overall score for validation B point is 7. B7 you add here 7 plus 7 14, 14 plus 5 19, 19 plus 6 25, and A will be 3 plus 5 8, 8 plus 7 15, and 15 plus 6 21. Now C category for savings, C3 and C7. Okay. Now we have to go with the C category, right? C having 5 plus 7, 12. And here on C3 in the sense 15. and here C5, 15 plus 5, 20. And D, implementation time, for which D 5.5 plus 3, 8, 8 plus 5, 15, 8 plus 5 is 13, 13 plus 3 is 16. And last one is the category called E. E is 18. How it is 18? E5 plus E5, E10, E14, 14 plus 4, 18. Okay, so like this, you need to give the first, you need to complete this matrix, this value, which is having the highest score. Okay, now you need to go for a decision matrix to decide the ideas, because we have collected many ideas, right? We have collected many ideas. Which idea is the best idea? Okay, now you listen this very carefully. So here to E, 5 parameters having the whatever the score we got in the pair comparison, you have to put it here. And now I'm going to compare. I'm going to give the rating out of 1 to 10. Okay, I'm going to give the rating in the range of 1 to 10 for the 7 ideas, because this 7 idea is been finalized one. Okay, so the ideas includes to eliminate the stiffness support by going with higher grade material, and there are many ideas. Okay, and one of the other idea is to optimize the wall thickness, and also to eliminate the non-rips areas. Okay, these are different ideas. Okay, let ideas be as it is. Now what I have to do is I have to give the rating 1 to 10 with the help of the cross-functional team. All the team departments, cross-functional department or multi-regional team will give the rating. Okay, will give the rating. What they will give the rating? They will give the rating considering what will be the development cost. So when I go for this idea, when I go for eliminating the stiffness support of oil pan by using the higher grade material, the team gives 5 points out of 10 for this idea, and they give 7 points for this idea. So for each and every individual idea, they give the rating. Okay. Similarly, for the validation time, they give the rating individually. Similarly, for cost saving, they give the rating individually. For implementation time, they give the individual rating. And for sustainability, they give the individual rating. Now, what you have to do is you need to add all the things. So here, you have to multiply. How you have to do is 21 into 5, 21 into 5 plus 25 into 5 plus 20 into 8 plus 16 into 7 plus 18 into 8. Overall, you get 646. So this is how you have to do. You have to do the matrix. You need to decide the matrix. Decision matrix here indicates you need to decide with respect to the paired value, paired comparison, what you got in the last slide. So similarly, 21 into 7 plus 25 into 2 plus 20 into 7 plus 10 into 2 plus 18 into 5. Put together, you get 459 points for this idea of going for a relocation of the mounting arrangement of the mounted parts of oil pan. And for optimizing the wall thickness of oil pan, going with the advanced manufacturing process, the team had been given 6 points to development cost and 6 points to validation cost and 8 points to cost saving and 5 points to implement points, and for the sustainability 7 points. Same procedure is being repeated here, and you need to repeat it for all the ideas, and you have to select the best ideas having the highest point. So 646 highest one. So this is the first number one idea. So the number one idea is to eliminate the stiffness support in oil pan by going for a higher grade material. And second idea is to optimize the wall thickness by going for advanced manufacturing process. And the third idea is to eliminate the rips and bosses. These three ideas been taken. And what is the you see here? When you go with this idea, the oil pan having initially 31 kg is been reduced to 19 kg. You see almost 12 kg weight reduction. But you see the function remains same. What's the function of this oil pan? Oil pan is to support weight, right? So these sort of ideas. The ideas include to eliminate the stiffness support of oil pan, and the wall thickness gets optimized. Then even the volume, I told you some 16, 30% volume reduction, right? So put together, you are going to get almost 12 kg weight reduction for this oil pan. Almost good cost, good weight reduction, right? And next one is the crankshaft. Initially, the weight is 24 kg, and next the weight reduction is 2 kg. And now here you are going for a alternate material by having grade 1541 SAE in material. And here I told you you are going for a web optimization. You are going to reduce the thickness by providing the kidney shape. Kidney shape means how our human kidney looks. Same type of slot design is being used for this optimization of web. Okay, when you see the cut section, I think it is my cursor is moving, right? Just let me know if it is not moving. Uh, when just imagine this is just you can go for a cut section now. Now use your now you use your some imagination. Maybe what you have studied in engineering graphics, like you do the cut section, right? When I cut the portion of the highlighted red, it looks like a slotted cross and looks like a D shape, kidney shape. Okay. Good. So even the heat treatment process gets optimized. So overall, here even the 2 kg weight reduction is there, and you go for the third material means product called water pump. So what is the function of the water pump to transmit power? And here the pulley material, it is having the pulley, right? This is the pulley. Initially, the pulley material is cast iron. This material is cast iron. They will change it to a sheet metal, and almost 1 2 kg again it gets reduced here. And even the fan adapter is there. It's changed from aluminum to sheet metal, and they are doing the optimization design of the fan adapter. Okay, so put together, what is the advantage of all three? Okay, so here oil pan, crankshaft, and water pump pulley. So the function is not going to get affected. The function is to support weight, to hold oil. To hold oil, you're reducing the volume, 30% reducing the volume, and to support weight, you are going to eliminate stiffness support, and we are going to optimize the valve thickness, and we are going to eliminate non-functional passes and the ribs. And for the crankshaft, what you're going to do is you're going for a alternate material, and you're also going for a advanced manufacturing process, right? So here you are going for a controlled cooled cooling process of manufacturing it to improve on the weight on the reducing the weight actually basically. And you are going for a kidney shape design of web for weight for thickness and weight optimization basically. And you're going for the optimization of heat treatment process. For water pump pulley, I told you you are going for a change in material of pulley to a cast iron, and you're going for a inbuilt design of a pulley and fan adapter, and finally you're going to withstand the force. This is a function. So change in fan adapter material from aluminum to sheet metal. So the management had approved this project. Overall, put together, the overall weight saving is 16 kg. Okay, 12 kg for crankshaft, sorry, oil pan, 2 kg for crankshaft and 2 kg for water. But 16 kg weight reduction is there. Okay. Then afterwards, you also implement it. So these are the things. Okay. Normally, in any company, you do the development. It starts with the design. Then you release the design, drawing. You release the drawing. Then you go for a testing, in which the prototype development testing will be involved. The trial will be means basically some fitment trial. Basically, you need to, because you do that. Okay, because you are doing some optimization, you need to ensure that the assembly is going to fit basically. Design for fit and design for assembly you need to ensure. And see again, development indicates even the testing also. You need to do component testing and also the vehicle testing. You need to individually test the crankshaft, oil pump, water pump, and also you have to test that along with the vehicle. And you have to do the vehicle PPAP, vehicle pre-production approval process. And, then finally you have to do APQP. You have to go for a pre-production approval process for a complete vehicle. Then engineering change number, each and stands for engineering change number. And today afternoon, one person, Mr. Satyanarayan, he will be explaining the process how normally they do. And again, it will vary from company to company, but the process is very much important. How they follow, how they achieve the optimization, how they achieve the design process, how they achieve the value engineering in a company. That is very much important. Good. See now, look at this thing. Value is the vision. Okay, always any company will look into the value. Okay, value is their vision. Okay, the company vision may be different, but for the product, the value is the vision. And there is a term called FCWA. FC stands for function cost, W stands for worth, A stands for analysis. We have seen function cost and function worth. So this function cost worth analysis should be the mission. Okay, any company, any product. So this function cost worth analysis is the mission, value is the vision. But always, any company will always consider the function as the foundation for any product. Okay, now I'm giving only product only, but even this can be applied for a process. Anything, the function is the foundation. Okay, function is considered to be the foundation. But above all, what is important is fast is important. What is called fast? Function analysis systematic technique diagram. Because from the fast diagram only you are taking all the functions, which is a foundation to do the function cost worth analysis. Okay. So fast is said to be the martyr. Okay, to achieve the value engineering. Okay. Um, Good.